Good morning and good afternoon to all of you. Thanks for joining us today. My name is Haresh Malkani. I'm the CTO for CESMII. And we have a great program for you today. We are going to be talking about the Smart Manufacturing Innovation Platform. And in particular, this is a training session, one of the many training sessions that we are planning for you through the course of the next several months. And it is a specific training today for data modeling. And we have Niels Andersen, who's the Chief Product Officer of ThinkIQ. ThinkIQ is a company that is a partner with CESMII. They're members of CESMII as well as their partners on the development of the platform. And they will be spending most of the 90 minutes henceforth here talking about data modeling in the platform and how you can utilize that to set up your use cases and solve problems. What you're seeing right now on the screen is our articulation at a high level of what the CESMII SM platform is. And today's focus is going to be on that middle layer that's labeled as SM Platform Enabler. It's all about the management of information, the modeling of that information, and the management and the storage, and how to make it available for all the applications that sit above it that want to consume that data and the information. So with that, I would like to just hand it over to Niels. Niels, the floor is yours.
Thank you, Haresh. So we have 90 minutes today, including the 3 we just spent, and we have quite a packed program, but I think we have enough time to go through this. As a training class, this is not a hands-on training class, so you will be watching me explain what I'm doing and what I'm building. I hope we can create more of a hands-on training class later where all the participants can join in. On the agenda, you see here, we have a number of items. The first thing I just want to have a short use case about what are we trying to build here. Then we're going to dive in and just look at some of the underlying architecture of the platform enabler, of the core platform, and some of the building blocks, some of the vocabulary you're going to hear during the training class. Then we have 5 labs. One is creating a reactor system from an existing type. So we have things that are pre-built in the system I'm working on, and just to show how quickly we can build a new reactor system on top of it. Then we are going to talk about the concept of relationships between equipment and how we can set that up and visualize it and use it. We're then going to talk about how we can build a new type, in this case an extruder equipment type. We're going to talk about how we can import and export type systems. And then finally, in Lab 5, we're going to talk about how we can use GraphQL as an API towards the model, in order to be able to read and write data from the model. And then all the way at the end here, we have a little bit of additional information about the applications that ThinkIQ built on top of this platform, just so you can show some of the capabilities that is available to extend the platform. Throughout the session, I would like that people actually ask questions using the question and answer box. You're muted, so we can't hear you. But if you can type in questions, Haresh will look through those questions and pick them up as we go. And the reason we would like to get the questions in as we go along the class here is just that if there's something you don't understand in Lab 1, it may be too late when we get to Lab 5. So starting with a use case, we have this fictitious company called Acme Corp, and we all know that if you've seen any of the demos before that we have done together with CESMII, we know that they're making food and beverages. They extended their business into synthetic unobtainium, and by the way, this class is assuming that you have seen some of the capabilities of the platform before. We're not going to go through install, we're not going to go through configuration of connectors and so on. So if you haven't seen that, you can go back and look at the videos that we have recorded on those topics. But they're making synthetic unobtainium. One of the reasons I picked that is because no one knows how to make it, and therefore no one can criticize the model we're building. It's just a way to make it simple. They already have the CESMII Smart Manufacturing Innovation Platform installed, and they have a Wonderware system platform, or Viva system platform it's called today, on premise, and they have a Wonderware historian that we are connected to. They see an increase in demand for this unobtainiums, in particular the synthetic type, and they need to add capacity, so therefore they need to expand the reactors and processing capabilities for it. And they are also running into the problem that most manufacturing companies run into these days, where there is very limited staff on the plants. The plant's called LA23 in Los Angeles, and they need to get help from their corporate engineers in Area 51, and they need to get visibility to the data and get access to the data so they can run their own algorithms on it. At the same time, Acme Corp has a number of headquarter-funded projects that they want to keep in mind. One is the project around digital transformation. We see a lot of companies have that now. And it's not just digital transformation within manufacturing, but across their whole enterprise. We're going to be specifically focused on manufacturing and supply chain. And within this, there's a concept of standardization and giving data meaning. They have gone through the process of trying to build a data lake with no structure, and understanding that data without meaning is just bits and bytes. It's very difficult to use. And they also, in the digital transformation, wants to enable advanced and flexible analytics. They have projects around yield and quality improvements, and then they want to have projects around extensibility and easy access to data remotely. So the task we've been given is to give the manufacturing data meeting, expand the plant with additional capabilities, and show how we can fit the data together. So first, a high-level data architecture, so you just know what is behind here. We typically talk about systems in three big chunks. One is on-premise, which is typically where manufacturing is happening. It could be in a truck as well, so it doesn't have to be on-premise. On here, we typically have a SCADA system, MES systems, proprietary system, ERP system, and so on. And we feed data from them through what is known as a Smart Manufacturing Innovation Platform connector, also known as a SMIP connector, into the cloud. Then in the cloud, we have the ability to ingest and process the data coming in. We have the ability to store time series data with the ability to store a type and instance model. And we also have an analytics execution engine that can take the data and process it and give it additional value. On top of this data model, we have a content management systems where we can build applications. And all of these applications, the content management system is a web-based system. So all the clients are web browsers or web APIs, where you can then, we're going to show you this today, you can go in and model it, you can do operations, you can look at trends, and you can also do third-party integration. In the demo today, specifically, the training class is using a Wonderware historian using the InTouch Reactor demo. We just use that because it's a very simple system that has data automatically generated. Be aware that some of these applications, such as Material Ledger and the quality data, are ThinkIQ applications built on top of the SMIP platform, so they're not included in a core platform. And the training class is leveraging Azure cloud hosting. Any questions about architecture before I move forward? Okay. So the first thing, look at the building blocks and how do we model, how do we put things together? And within our system, we have two basic models. They're very closely tied together, but one is a type system model, another one is an instance model. And this is very similar to an object-oriented programming, a class-based system. So the example on the right-hand side here show you have a base vehicle class, and on that you can derive a sedan class or truck class, an SUV class that has additional capabilities beyond the base vehicle class itself. We support composition. So unlike what is shown in this diagram here, you typically wouldn't put the horsepower on the base vehicle class. You would typically go in and put a motor in there and the engine in, and the engine would have horsepower and so on. And we can assemble these cars in an intelligent way, or assemble the objects in an intelligent way. Within a type system, we're going to hear some terms such as libraries. Libraries is just really a namespace, a way to group together different type systems to avoid getting name collisions. So if two people go in and define what a car is, they can exist in two different libraries and have two different declarations of cars. We have equipment types that can be composites. We have something called attribute types that are quite unique and outside the typical class system. It is a use case we've seen very often in manufacturing where you can't create classes that are types or templates that are exactly the same. So you can go in and define that an attribute type has a meaning. It's almost like a small interface where we can go in and create a vocabulary to say that, for instance, power efficiency has a meaning independent on whether it's power efficiency on an internal combustion engine or an electric engine or a heat exchanger and so on. It still has an efficiency of how it's using power. And that is a very powerful capability that allows us to do analytics on top of the data independent of which class it's derived from. We have a whole system of measurements, quantity kinds and measurement units. This is based on the standards out there from United Nations and QUDT of how we can then declare that meter is a measurement of length, and length is a quantity kind, and so is inch, and we can do conversions between them. We have the concept of relationship types, and we're going to actually drill into that, but it allows us to go in and create what is typically known as a semantic model where anything can relate to any other thing in any way. And then we have scripts, that is logic that can be associated with equipment types that can then go in and give the equipment types and the type system itself capabilities and meaning that can be executed at the instance level. And then at the instance level, you will see we have organizations, places, equipment, connector, relationships, and this list is much longer than this. So in lab number 1, we are going to go in and create a reactor system from an existing equipment type. So I'm just going to go through, what I want to do here is just read through what I intend to do and then do it, and we can go back and revisit it so it's possible for people to follow what we're doing. So the starting point we have is that we already have a equipment type called reactor system type, and it is a composite equipment type, and it has attributes on it such as content volume and content temperature, and it has child equipment that has an inlet valve, an outlet valve, a steam valve. All of these are actually equipments of type valve, and then it has inlet pumps, outlet pumps that are of type pump, and you will see how this composition is put together. We're going to create a new instance. Reactor 01 already exists of the reactor system type. We're going to call it Reactor 02. We're going to locate it in the plant LA23. And then we're going to configure the attributes to point to the tags from the Wonderware historian and look at the data in a trend. So if I can find my web browser here. So now we are inside the platform. We are going to, this is just when you take an empty system, default system, install it. This is the default home screen you get. You have a menu system on the top, and we are specifically now going to go into the part of the menu system where we are modeling, and we're specifically looking at the physical model. So within the physical model, we have created a model environment that is quite tabular compared to what we see in many other object-oriented environments. And we've done that on purpose. And it's because we've seen it's a very effective way of working with very large models, where you want to be able to go filter and search what you want to work for and then work on, and then pick that element and do work on that element. So the first screen you see here is an organizational structure called Places. And you see we have our Acme Corporation. We also have 2 other corporations that happen to be suppliers to the Acme Corporation, Flowbix and Initech. And underneath the Acme Corporation, we have the food business unit that some of you may have seen before. We have the rare elements business unit that we just created, and then we have corporate engineering and R&D. And underneath here, we have plants. We just put 2 plants in here, LA23 and New York 11. And within the plant LA23, we defined areas that are processing, packaging, and utilities that are within this plant. So you can build this model, you can import the model, you can create these type of hierarchies, and they're there to give you a namespace and a way to navigate in the data so that you can have 2 places called processing, for instance, one in the New York plant and one in the LA plant, and it knows that there are 2 different places. We also have, in the other tabs here, we're not going to go into all of them. We're going to equipment types. We're going to start and look at now, we've got equipment, which are instances. We have equipment with attributes that allow us to work on a list of attributes across all equipment types. We have the ability to create relationships, and we're going to go into that later. Attribute types is the vocabulary of reusable attributes. We have a view into the tags that is being pushed from on-premise. Then we have measurement unit quantity kinds, which is the measurement systems. And then we have a script, and we have the libraries we're going to look at in the end for importing and exporting. So going to equipment types here, we want to start off with the type we want to derive from. I just want to explain what is in here. It's Reactor system type. We made it belong into the Acme corporate library, which is again, is just a grouping, a namespace of the type system. And we derive it from the Acme base equipment, and we're going to show you later what capabilities that give us. And by the way, we can reassign where we derive things from after it's been created, which gives a lot of flexibility in how we build the model. When I expand this, you see that we have some sub-equipment. We have an inlet pump, inlet valve, outlet valve, and certain steam valve. And you see these are derived from pumps and valves. And this is like an application. You see we have multiple pumps. We go in and say that this pump here is called inlet pump, but it's still a pump and has all the characteristics and capabilities of the pump. And if I add more characteristics and capabilities to the pump class that you see up here, then you will be able to get those capabilities on this instantiation as well. You will see here on the reactor system type, we also have attributes. And on the attributes, there are a number of attributes that are inherited. And there are also attributes from the Acme base type, but there is things such as content volume and content temperature that are specific to our reactor system type. And you will see the same thing also if I take the inlet pump, that there are, in this case here, a rotational speed and an is running state for the inlet pump. So the next element here is to go in and just create our reactor system 2. So we again go into our equipment tab. You see we have reactor system 1, and it is a composite as well. We are creating a reactor system 2, and we are going in and declaring that this here is an equipment type. Here you can just search the list of reactor system type. We also want to place this into the processing area. And you can see the processing area is in plant LA23, and we can give it a description. Reactor 2, for instance. We can also add notes, which are good for engineering purposes. They don't show up in the typical UI. If there's additional information about how you want to configure the system, for instance. When I submit this, it now creates reactor system 2 and the composition equipment underneath it. And the next element we're going to do is to start wiring up this. It created the attributes that are associated with it. So if I go into reactor system 2 here and say I want to assign attributes, you see it's created all the attributes that are on it. You notice that some of these attributes are config attributes that are static on the object, and some of them are dynamic attributes. And we're going to go in here and take the content volume and assign it in what's in the Reactor demo is known as the reactor level. That is a tag that we got out of the one historian. You can also see here that it automatically went in and created a measurement unit, a cubic meter. It knows it's a volume quantity, and it automatically created a description associated with the attributes. So that is the content volume. We can do the same thing with the temperature. You just go in here and say assign this to, you see it remembers what I searched on before, to the rack temperature, and it's now stored within the system. So those are all the attributes we're going to that we're going to configure at this point. Before I go in and configure the rest, I just want to do it, actually just configure them very, very quickly. We can go in and do the inlet pump. You see here, I choose the inlet pump. The only attribute I have associated with that is an is running, and it is known as a concentrate. Let's see, this was the pump, the concentrate pump. And if we go to the inlet valve, you will see that is now the concentrate valve. So here, position for the valve. That's a concentrate valve. And I'm not going to go through it. Seeing me clicking all of these does not necessarily add that much value to it. So what the interesting part now is that we configure this, and we can now go and say, well, I want to see what is associated with it. So we had already configured the historian. The historian is already streaming data to the cloud. If we had not configured the tag to be streamed to the cloud, it would configure it as we assigned it. But here I can now go and click trend, and it will take us to the trend application with the context of the Reactor system 02, and we can now see the data that came in from the historian on-premise into the cloud that is now accessible in the system. And if I want to go in here and say I want to have more of the variables associated with Reactor system 2, I can now choose those and say I want to have my inlet pump is running and my inlet valve position. And you can now see that we have included those in the data set that is returned from the historian that we have in the cloud. So that is the end of the first lab, and I see that there are some questions coming in here. Harish.
Yeah, Niels. Well, first of all, there's some crackling coming from the audio. I don't know if it's at our end or your end, but it seems to go in and out. So maybe if there's an adjustment, that'll be helpful.
Okay, is it when I move my head?
Not quite sure.
Okay.
So one question back at the early part of your presentation in the architecture slide, you were mentioning that there are analytical execution engines that you talked about.
Yeah.
The question was, what type of engine are we using?
Okay, so we have multiple capabilities. The most interesting capability, I would say, is the automated script execution. We're not going to cover this in this class. But in that, we run 3 languages. We run Python, and we can have access to the full pandas, NumPy type environment for running Python headless. We have PHP, so where you can do things that are more web enabled, and we have a library around PHP as well. And we actually have a SQL interface that is not quite as well developed yet, but that allows us to work directly against the database. So that's the automatic part of it. On the more ad hoc analysis, we have Jupyter Notebook. So you can go in and you can attach it directly to the data model and run Jupyter Notebook, run the same Python scripting that you run within the script engine inside the Jupyter Notebook.
Great, thank you. Another question, and this may require some follow-up discussion perhaps with the person who's asking the question, but it's around the thought that there are several folks who are sort of in that research and development mode where they have data that is stored in their own Excel or CSV formats. They're using some other tools like Jupyter Notebook to do the analysis, and then they have some sort of a application with a Docker container in a Linux OS. If they want to utilize this capability of the platform, how would you suggest that interface take place? How can they leverage this capability with that type of information?
So there are several ways to do it. We can load data from a CSV file. Maybe we should even create a CSV file connector that we can just run on premise, picking up CSV files and stream them into the time series data. But we can load that into the model itself. We can also, you will see at the end of the presentation, we will show the GraphQL interface that allows you to get access to the data and be able to run your own algorithms on top of it. And anything that I wouldn't say anything that's a broad word, but we haven't found anything you can't run against a Python infrastructure as long as you're using the same version of Python that we do. So there is a very extensive capabilities of both writing data and getting to the data. We do recommend that people avoid just doing a simple extract into a CSV file, because you lose a lot of the context and a lot of the meaning of the data. And by doing that, I think that if you lose the meaning, the value of the data is much less than if it exists within the model.
I think the other thing I would add that to your answer, Niels, is that in the near future, we will have the ability to create what we are calling the SM profile, based on this capability in the platform. And once that is done, we envision several ways in which we can use things like translators to go back and forth between the platform and any other external system through that. So, one more question on the instances of equipment. Can equipment instances have individual differences? For example, if one reactor has an extra pump but is otherwise identical.
Yes, I actually think the best way for me to do that is just to show it. It's a very good question, and it's one of the big differences between computer science and manufacturing engineering. In computer science, they call the classes look the same. In manufacturing engineering, cannot. So if I went in here and said a reactor system 2 has I want to go in and create an additional pump here, I can just choose reactor system 2 and say add a equipment instance here. Let me see here, and then I'm going to go in and call this just a CESMII pump, and I'm going to make this a pump, and I want to have the local library one, actually that one, and then I want to place this in Reactor System 02. And what you will see now is that Reactor System 02 now has the CESMII pump attached to it. We can do that both on the equipment composition and on the attribute level. And another thing that you can notice that the attributes that are not used are hidden in the system. We see a lot of people struggling with creating classes that have so many attributes. And then when they try to trend it, for instance, or show it within the user interface, they're completely overwhelmed with all the things they didn't use. And they never can get to it. They don't have any understanding of which one of these attributes actually have data. And we basically only turn them on if you either set as a configuration variable, or if you go in and assign it to a tag so there's real data associated with it.
Yeah, Niels, your voice is still breaking up several times. So
okay,
an alternative.
Let me try to switch the audio here. Is this better?
Continue talking, and we will.
Can you hear me now?
Yeah. Well, we'll give this a try in the next question, then we'll see how that goes.
I apologize for that. So.
Another question is, would the organizational structure that you're showing extend into supply chains, or is there another way to define a supply chain scenario?
So yes, the organizational structure can extend into supply chain. Which is what I try to indicate here with the suppliers, Globex Corporation and Initech Corporation. We have not done that much with it yet. We have material flow from some of our customers to go across multiple factories and so on. But we still have some extensions to add in order to truly tie it together in a whole supply chain. But there's really nothing that stops you from tying together suppliers into this model as well. And by the way, everything in the model is fully accessible through URL, so it allows us to tie together two different systems as well.
Great. There are two more questions. I don't know if they apply to this section or would be better answered a little bit later. I will state them, and then you can determine if that's something you want to do now. There are plenty of vendor-supported and open source flow sheet modeling tools out there. What is the differentiating characteristic of this offering?
So I really would like to see what they're referring to before I differentiate it. We really just try to build a model that have meaning, where all the data is tied together in a way that makes it very accessible and can have a visualization on top of it, an execution engine on top of it, and tie it all together. I would love it if there are systems that we need to integrate to or learn from. So please send over examples and I'll take a look at it.
Okay. And again, I'll leave it to you if you want to answer this later on, but how can we integrate this platform with conventional modeling software like Aspen or gProms?
Yeah, so this is where, Haresh, you mentioned SM profiles. And there are projects going on right now to automatically create profiles. You would see a simple version we have, which is just the import and export of JSON files. But we can create connectors that take the profiles and the structures, both these type system and the instance systems, and tie them together with tools such as Aspen or OSI, Asset Framework, and so on.
Right. I think the other thing that we are hoping to have is I think you mentioned this as a GraphQL interface into the structured data. So that would be the means of communications between the applications that are using the data and the data itself. The dashboard that you were showing, will that form a backbone of the SM platform?
I assume you're referring to the trend?
I believe so.
Yes. Yeah, so that is part of the SM platform. I wouldn't know if it's a backbone, but it's...
Yeah. Okay. I think we've answered the one around the org structure for supply chain.
Yeah, I see that there's a question there from Charlie Gifford. And Charlie, if you can, we can have an offline discussion. I would love to see how we can make this even better with regards to ISA 95, but it may be more of an offline discussion if that's okay with you.
It's fine. It's very good. Okay.
Oh, okay.
All right. Thank you, Niels.
So let's go to lab number 2 here.
Yep.
So, and this actually is a 2-slide lab when it comes to relationships and equipment, between equipment and graphs and so on. I have been in many MES projects where we really struggled with the ability to go in and declare any type of relationship between any 2 pieces of equipment. And there was always something that the software supplier had not thought about, and we were really struggling with tying together. We did a lot of research into a field called semantic web and discrete directed graphs and discrete mathematics, and see how we can go and create these things called triples. And what this allows you to do is to express that anything can be related to any other thing in any way. And this is typically expressed as a sentence, as a subject, predicate, and object. That's also known as a triple. And in some environments, you'll see this referred to as vertices and edges, or nodes and edges. And just as an example is that Niels which is the subject, is working for as a predicate, and ThinkIQ is an object. And now you can put together sentences expressing almost anything. So in the Smart Manufacturing Innovation Platform, we created the concept of a predicate or an edge as a relationship type, and then the triple as a relationship in its own right. And with the platform, we can create new relationships, relationship types, and we can create relationships between. And just for making sure there's no confusion about the word graph, most people, when they think about graph, think about like a trend graph, like the one I have here. And that's not the type of graph we're looking at. It's a graph that is the discrete mathematic graph, where things are tied together, and a circle here is a vertex, and the line is an edge, or the circle can also be referred to as a node. So when it comes to creating relationships between equipments, the starting point that we want to have is, the starting point we have is that we already have a number of relationship types. We have one that can feed, that shows how material can flow. And then we have this one that says can feed electrical power, which shows how electrical power can feed. And there are some relationships that will show you this that's already been built, so you don't have to see me creating too many relationships. And there are some pre-configured, what we call network diagrams, that show up as process layouts or utility layouts. And I'll show you those before and after so you can see what happens. So in this example here, we're going to create some new relationships. Reactor 02 that we just created can feed materials to the unobtainium tank 01 that we have created earlier. And we're going to set up the MCC 101, so Motor Control Center 101, can feed electrical power to the outlet pump and inlet pump on reactor system 02. So let's go in here and just look at these layouts before and after. So I just created a process. You can create as many of these layouts as you want through the content management administrator. I created one that's for plant LA23. And you see here that the reactor system 01 is feeding the unobtainium tank 02, that then again is feeding the unobtainium tank, unobtainium bag filler, and 3 bottle fillers. And on the utility side, we have the main electrical meter feeding the MCC 101 that feeds the outlet pump and inlet pump here on the reactor system, so within the composition model. So going into the equipment view here again, we are now going to take reactor system 2 and we're going to add a relationship to it. And here you go into the relationship editor and we're adding a relationship that says that this can feed materials to the equipment that is known as unobtainium tank 01. And we added that to it. And then we, in addition to that, you see here there's now one relationship. We're going to go in and we can go in and look at the MCC 101, and you see MCC 101 already have a number of relationships. It has a relationship from the main electrical meter. It can feed electrical power to MCC 101, and it has two relationships from MCC 101 to the inlet pump and outlet pump of reactor system 01. So here we're going to go in and add the relationship that we can feed power to, and I'm just going to find our pumps here. So I'm going to find an inlet pump on reactor system 2, and do the same thing, can feed to the outlet pump of reactor system 2. So now we define those relationships, and as we showed before, we can go in and now look at the diagram. So clicking here on processes and going to plant A23, you now see that we have reactor system 2 feeding into unobtainium tank 01. I want to draw attention to a couple of other things here as well. You see that we have live data flowing into this diagram here. And so that you can use it as almost more of a dashboard or a way to have key performance indicator. It's not supposed to be an HMI replacement or anything like that, but it builds automatically and allows you to feed the most important data you want to go in for the type of view that you're on. Other things that is important to understand is that I can click here and now I can navigate in the model. I can go in to look at the details of the equipment. I can go to the model editor, I can go to the trend, or I can go to any of the contained equipment underneath here and look at the trend data associated with it. So if I, in this case here, now wanted to go to my reactor system 02 and just look at the trend, I just click on the trend and it navigates and takes me into that part of the system. We're back to the trend that we saw earlier in the system. So it really allows us to tie these elements together. And the same is also true for on the utility side. You can now see that we have the MCC 101 feeding into the outlet pump on the reactor system 2 and the outlet pump on reactor system 1. So it shows the composition within the model itself. So that is really what I would want to show around relationships. Any questions about this type, this approach?
Niels, there are no questions. We were just wondering if it would help to perhaps improve the bandwidth if you turn the video off and see if that helps the quality of the audio. It's still crackling a little bit at times.
Okay, let me turn off the video then.
But there are no questions in the section. Actually, there is one question. Your relationship seems to be defining equipment trains. Can you define the relationship view as material flow?
Yes, you can. You can define any. So what I defined here in the first element here was how material can flow, and what we also do is that we define how we use sensor data to determine material flow, so that based on conditions that material flow happen, and that we store into the material ledger, which is similar to a network diagram, but it has additional capabilities because it has ledger entries with amounts and start and end times that are more advanced than a single can feed relationship here.
Okay. There's another question. Can we use existing PFD, PID, operating schematics, etc., to decipher the relationships?
Yes. So I'm not quite sure if I understand the full extent of the question here, but so we have an API where we can build the model. So if you have an existing system and you want to go and automatically create the model from there, existing P&IDs, process flow diagrams, you can absolutely do that. Other than that, I'm not quite sure I understand. Haresh, do you understand?
Yeah, we can follow up, but I think, you know, if you already have a structure that's already defined through these other mechanisms, through other flow diagrams, how do we best capture that or import them? But maybe it's something that we can follow up offline. Another question around, does the platform fill any missing data or look for abnormal data?
You would have to, right, I mean, you definitely have the tool sets allow you to do that, but you would have to create the algorithm and run that as a script on the data itself, so that we don't try to make up data. We try to store the data that is being given to us from the sensors, but we can create additional data if you have an algorithm for that.
So in other words, you know, cleansing of data and filling out the missing pieces is done before we capture it in the platform.
Correct, but you can write an algorithm if you want to have a script that goes in and cleanse. Say you want to put a Butterworth filter on your time series data, you can go and do that and then store the data again as a filter data set if you want to.
Okay, good. I think that is it. There's one comment. I'm not sure if it's a question or not, but it says, so maybe the person can articulate that a little bit better. We can ask the question. No further questions at this time.
So then get on to lab number 3, where we are creating a 3-zone extruder equipment type. And again, we have a starting point here, just so you don't have to see me build all of these different elements. Just kind of go into the core piece that needs to be built. We already have a basic extruder type has a screw motor attached to it. We have the concept of extruder zones, and we have attribute types that we want to reuse that gives data meaning. And what we're going to do is to create a 3-zone extruder type, and we're going to derive from the basic extruder type, and then we're going to add this 3 zones to it, and then we're going to add a constant temperature set point to each zone, and then create an instance of this and show how it propagates. So if we go to the model here, back to the physical model, you will see that in the equipment type, we already have an extruder. An extruder has been defined to have a screw motor, and the screw motor here has attributes associated with it, and the extruder has attributes associated with it. We also have something called an extruder zone, which is a reusable component, and it has 2 attributes on it. It has a constant temperature and a constant temperature set point. And I'm actually going to go in and just for now just delete this because it should have been part of the demo to create it. So I'm just going to take it away so you can see how propagation works. So what we're going to do now is to create a new equipment type, and we're going to call this spelled properly. Pick it here, a 3-zone extruder, and we're going to make it inherit from the basic extruder type that I showed you earlier. And we're going to put this into the extruder library and store that. So now you see that we have a 3-zone extruder, and it looks exactly like the extruder we derived from. But we're now going to go in and add 3 zones to it. So we're going to have a zone 1, which is a feed zone, And we're going to say that this zone 1 here is an extruder zone. We're going to add a zone 2. It's a good thing I typed this before, so you don't have to look at me typing. There's also an extruder zone. And actually, we'll make sure this is an extruder library. And we want to add a zone 3, which is a metering zone. And again, it is also an extruder zone. And I think I added number 2 here incorrectly. I added as a base. Let me just delete that for a second. And I'm going to add the number 2 here onto my 3 zone extruder. So we now have a 3 zone extruder. The extruder has a screw motor, the 3 zones associated with it. And you see that on each zone, we have one attribute, which is the constant temperature. We're not going to wire it up. We're just going to create an instance of this extruder. So we're going to create extruder, create a 04, just to give a new number. And we're going to say that this here is a 3 zone extruder. And we're going to place this again in the processing area. And we now have a extruder 04 with all those elements to it. And we realize that, for each zone, we actually want to have a set point. So the attributes here, they only have a constant temperature, we don't have a set point. The way we can do that, we go in here to the equipment types, and on the zone itself, we will find my extruder zone. Here, we will go in and add an attribute. And one of the things I've seen in many manufacturing systems that really makes it difficult to use is that on every single template, on every single instance, or every single tag, we give them different names. We go in and we say that these, they get spelled a little differently, and it just makes it difficult for the user to understand and for us to use it when it comes to analytics and reporting and optimization. So we're going to go in here and add an attribute, and we could type in what the attribute is from scratch if you want to do that. We're not going to do that. We're going to go and choose from an attribute type that already exists, which is known as the constant temperature set point. And we can reuse this constant temperature set point on anything that has a constant temperature. We want to have a set point. Now we can do comparison between constant temperature set point to the constant temperature itself on a piece of equipment. And it automatically has meaning within the system. And you see here, it has been giving a data type of a float. It has been a default unit of degrees Celsius, and it has a quantity kind. If I want to override and say this one is a degree Fahrenheit, I can do that on the type level and on the instance level itself. And the system is smart enough to understand how to do unit of measure conversion. So now by adding that, you will see that the zones on my type now have the constant temperature set point. And you will see that the equipment instance we created here, each one of these zones also have the constant temperature set point. So it propagated throughout the system. See that for each one of them. So that is just one way we can show how we can create a class. We can now wire it up. We can do all the things we did with the Reactor tank. I also want to show you some other capabilities regarding how we tie things together. Quite often we recommend that people go in and they assign things to a base equipment type, for instance. They can go in and then add functionality to that base equipment type. So we could go in here and take the base equipment type, which is up here. Sorry about that. And now say that on this base equipment type here, we can now add additional attributes. So imagine that we wanted to go in and create a ERP asset ID, because we want to, in our analytics, we want to be able to tie together what is in SAP to what is actually in this model. And again, I can very effectively do that by just adding an attribute here. I have an attribute type already that is called ERP asset ID. And these ERP asset ID, I can now go in and say, this is a config attribute. And by making a config attribute, I can now type in at each system or load into each system a configuration value that is not tied to a tag. And now every single piece of equipment that is derived from the Acme base equipment, which is a lot of the equipment we have here now just got an ERP asset ID. So it makes it really easy to propagate information within the model itself. So that's the completion of live number 3. Are there any questions around this?
I don't see any questions on this segment. Someone is raising their hand. Wait to see if there are any questions there. Please type in your questions in the Q&A box, please. Okay, is there a way to organize attribute types?
The only way we have to organize attribute types right now is that they belong to libraries, just like other things in the type system. I will show you that when I do the import and export. But that is one way to organize them. We have looked into creating attribute type derivation, and I think it's something we may want to do, but we're a little concerned that maybe too complex. We want to see how this works out first. And that would allow us to go in and make an attribute type a subtype of another attribute type, which also would create what is known as a taxonomy hierarchy. But right now we don't have that. What we have is we can put the attribute types into libraries. Okay.
Very good.
So
okay, there's one just popped up. What are the limitations to create a new attribute type?
okay, I think so what defines an attribute type? Let me just create one. I think it might be easier. So we go in here to the model and the attribute types. And I'm going to create a new attribute type. And this attribute type I'm going to call a CESMII attribute type. Okay. And when we create the attribute type, it automatically right now gets assigned to the local library. It's actually an enhancement we're working on right now. You give it a description, basically says what this attribute type does to help you decipher it. You give it a data type. So in this case, you want to make it a float, and then you assign it a default measurement unit. And when you assign a default measurement unit, what you're really doing is that you're setting the default measurement unit, but also setting the quantity kind. In order for an attribute type to have meaning, it is okay to go in and change. So say I want to have a length quantity kind. It's okay that I set my first one to meter, and then when I instantiate it, I say it's in foot, because these are both of length and I can convert between them. But I can't go in and convert between length and speed, for instance. They are two different quantity kinds and they cannot be converted between them. So if I went in here and said this here is meters per minute, now I've created an attribute type. And if I want to add that attribute type to an equipment type, say we want to add it to our pump here, for instance, I can now go in and say add an attribute, and it will take the context of the attribute type, and take its name and the configuration and carry it over into the system. And we believe this is quite important when it comes to structuring your equipment. It's almost like a small interface in the programming world, where you have consistency now across multiple types of equipment without having to have them all derived from the same class. Okay. I hope that answered the question.
Niels, just one, I think this is maybe a question / comment from me, that the process that you just showed about creating attributes and so on, could you comment on how that relates to the development of the SM profiles that we are going to be having as part of the platform structure?
So some of those questions are still open. You know, we have gone in and created a strong approach, really around the type system, which are very similar to the profiles. And I will demonstrate that so you can see how profiles are imported and exported within the system. But the intent is that the profiles would be aware of attribute type, but that is not something that we have a decision on yet. So, but we definitely believe that it is a powerful way of giving data meaning, so it is not just a tag with a cryptic name.
Great. And a related question, is this available for general use as part of the SM platform to develop profiles? There's actually a two-part answer to this. I'm happy to answer one of the parts. But yeah, I think this what Niels is showing here is sort of quote unquote manually creating data structures for your use. What we expect to have a SM profile builder, which will be part of the platform, which will sort of directly allow you to create these profiles. And then, like Niels was saying, there would be a way to transform the profiles back and forth into the model that Niels is showing here.
And also, I just want to make another comment as well. You know, we have a lot of work going on regarding the connector, and the connector is completely based on OPC UA, and it is our intent to be able to communicate profiles through the connector, or we call it the gateway, which is a common element across all the connectors into the model, and that is a way we can transport from an edge system or a engineering system into here and create reusable classes or templates. And I know that when it comes to any questions about availability to these tools, that Jonathan Weiss couldn't be here today, but he directed any questions to him about availability, and he will handle that.
Very good. Thank you, Niels.
So the next element here is about import and exporting type system. And I've cheated a little bit. I've created a little type system, which is an example dairy type system. And I'm going to import that. And we're going to talk about what does it mean to import and export libraries. So going to the libraries tab here, you see we currently have the 3 libraries within our system. We have the Acme Corp library, we have the Extruder library, and then we have a local library that comes with any system. And in here, we can create more libraries if you want to. And now we're going to import a library. So I'm going to import here from a library I created earlier, the dairy library demo. It is a JSON file. And when I import this, I can choose how I want to deal with duplicate records. So update will say that anything that I imported already exists, and exists in terms of what is known as a fully qualified name within the type system, will be updated. If it's a script, it says that it's going to ignore anything that exists that is being imported. Newer means that it will take the one with the newest updated timestamp, and replace means that it will go in and replace, in particular, composite equipments. So for instance, if you have an equipment type that has child equipment on it or multiple attributes, it will actually also go through a delete process for the ones that don't exist in the import itself. In this case here, I'm just going to do an update and do an upload, and this now loaded the library in. I have to do a quick refresh here. It's a lot of data being loaded, so the model editor would like to be refreshed, but now you can see we have the dairy library included into our system. And inside this dairy library, we have multiple elements. We have equipment types. And within this equipment type here, if I go in and say, I just want to see my dairy library, you can see we now created a butter churn, a homogenizer, a high temperature short time pasteurizer, a milk evaporator, and a milk separator. And underneath here, you see we have inlet pumps, inlet valves, and so on. And they are all derived and tied to systems. What is interesting to note, though, is that a library can span, so something that's inside a library can span into other libraries. So in this case here, the HTST pasteurizer is using a inlet pump, having an inlet pump, which is classified by the pump existing in the local library. And that allows you to create reusable base components that you then can go in and use in many industry libraries. And I'll show you when we export it, it will actually take any dependencies you have with it and export it out into the system. So if I go in here and just go to a JSON formatter, I'm sorry, I don't have a good one on hand, so I'm going to use the one that's online, and I'm going to just open up the dairy library to show you what is in there. You can see that inside this file here, this is a JSON structure. It has some meta information about the file version and where we exported it from. If there was a specific library export, in this case, we exported the dairy library. It has the information about what libraries are included. So even though we just exported their library, you see that it actually took the dairy library and it also included the local library because there are dependencies on it. It also went and exported all the quantity kinds that we needed. So in this case here, we needed angular speed quantity, electric current quantity, and so on. And it exported all the measurement units that were needed in order to build a library, such as ampere units. I think there's a voltage unit here as well, like a centimeter cubic foot unit, and so on. It created a number of equipment types that you saw on the list here, and these equipment types here, where things such as the butter churn. The butter churn, you can see, has no attributes, but it has 5 child equipment. And these child equipment here are things such as an agitator motor. And you see each one of these elements here has been linked together with what we call these fully qualified names so that we can intelligently tie together these structures through imports and exports. And if I now go back to our physical model here and back to our libraries, I now, on the export side, I have 2 capabilities. I can either go in and I can export all libraries, and it basically just creates a JSON file that has anything that is in this structure. Or I can go and export a single library. So in this case, if I want to export the Extruder library only, it does that. And I'm just going to open up this file. You will now see what is inside the Extruder library. Second here. Paste properly. So here I exported the Extruder library, and now you will see that the equipment types here include things. So the base equipment is a dependency. It includes the generic extruder, includes the extruder zone, and so on. In some place here, we probably have a 3-zone extruder as well. So you can see how it's all tied together within the system itself. So I don't know if there are any questions about import and export. And we have proposed that this is something that goes into the profile management, but we understand that there are parallel activities going on, defining what the profiles need to look like, and we will try our best to work together to make it all fit together.
Okay, any questions from the audience on section 4? I haven't seen any. All right.
So the next element here is around how we interact with the model, extend the model, and tie into the model. And this is not the only way to actually tie into the model. I think the most common way that people will extend the model is by building models themselves and then using our scripting environment, because you can then do it all within one self-contained unit that is backed up, managed, and taken care of. But if you have a third-party application, for instance, if you have a Raspberry Pi, or if you have a Savagin workflow system, or if you have any other system where you want to interact with our system and you can't put as a script inside the model, you can do this with an API, and we've chosen to use GraphQL. And just a little bit, I don't know if everyone knows about GraphQL. We've been down many different paths how we're going to do this integration. But GraphQL is a query language for APIs. It's a standard. It was actually created by Facebook originally, and then they made it an open source standard. And then it's a runtime for fulfilling those queries with the existing data, so you can read and write to the data. It provides a complete and understandable description of the data in the API, and it gives the client the power to ask exactly for what they want, unlike what we see in REST APIs, And it also allows the API to evolve over time as the capability to declare something as deprecated, for instance. And we have done development work for CESMII, and the GraphQL is the Smart Manufacturing Innovation Platform web API. So why not just use REST API? We talked about that briefly, but one is the REST APIs typically are purpose-built. And if you want to go in and link multiple things together, you need to have multiple rounds to fetch the related sources. And you know, why that might be not a problem if you only have 2 things. If you suddenly have 100 things you need to link together, it becomes very complicated. It also typically suffers from what is known as overfetching or underfetching, where the person who wrote the API defined what data should be returned, and that's what you're going to get. There's no way to specify if you want more or less. So as a quick demonstration here, if you go back to our physical model, I have a graphical interface. So the GraphQL is a programmer's API. Most people are never going to use this. They're never going to see it. And I'm using a visualization tool on top of it called GraphQL. It is a standard visualization tool that you can use to build queries. It is not the most normal way to do it, but I think it's the easiest way to document or give an example of teaching. So what you see here on the left-hand side is an explorer of the type of objects we have within the model. And then on this number 2 here, we have a query. And over here, we're going to get the results of the query. And then we have ability to show documentation. I'll show you that in a second here. So if I want to go in and work on equipment, you see there are 2 what they call nodes in GraphQL. There's equipment, which is singular, equipments, which I guess is good English from plural of equipment. But I can go in here and say I want equipments, which then would give anything with an S behind it would give us a list. Anything without it would give a single instance. So in this case here, I want to go and look at my equipment, and I want to get back my display name, which is what is human readable. I want to get my relative name. And if I just do that and click play here, you see now I have a list of all the equipment that is defined within our structure. So it gives you a very quick way to get to all the data and very easy access. And this query here can be run over a curl command. So you can delete from any language that supports issuing curl. You will do that and you will get this JSON structure back that will have the content of what you asked for. You see, I got exactly what I asked for. I just got equipment and I got display names and relative name. But say that I only want to have things that start with Reactor. I can now go in here and say I want to filter this, and I want to filter it on my relative name, and I only want the ones that starts with Reactor. And it now puts that into the query, and by the way, I could type it here, it probably is faster. It's not as easy to demonstrate. And you now see I only get the 2 items that have Reactor in it. So what about linking multiple queries together? Let me show you an example here where I want to have the attributes that are associated with this equipment. So I have my equipment, and I go down here and I say I want to add my attributes to it. And for my attributes, I want to have my ID, I want to have my display name, and I want to have my relative name. And now you will see the query returns for every single piece of equipment that I filtered on. It returns the attributes associated with that. And say that I want to again filter this down to only show things that start, that is say I only want to have a content volume. Let's copy this. My keyboard quickly. So I can now go in here and say only show me relative name that is equal to content volume. And then again, you now see I only get those 2 attributes. And just take note here, I have 2 IDs here. I'm going to use them when we go and get the time series data. You see how easy it was to interact with the model and to write something, and we can both read and write the model. If you have the right access level, you can write back and you can actually build a model through the same interface, what is known as mutations. I'm not going to create a second query here. The second query is going to be, I'm going to name this query here, by the way, equipment with attributes. And we're going to create a second query, which is going to get time series data. So you just go in, say add new query, and you can go in here and say, I want to have time series data. And in this time series data, you see the things with a colon behind it. And those colon are things that are required. So I'm going to go in here and I'm going to ask for the IDs 3158, and I'm going to have this little array here. And the second ID I want is 3602. Those are the two attributes. Okay. And then I want to go in and I want to go in here, and I also need to define the start time and the end time, and I need to define how many value points do I need to get. Maximum number of value points, max samples. And I need to define what data I want to get back. I want to get the timestamp back. I want to get a float value back. And I want to get the status, OPC UA status code, and the ID of the attribute I looked at. And then just to make it easier, I'm going to prettify this. I'm going to type in here the start time, 2020 06. What is it today? It is 16. And this is just an ISO format. Timestamp. I'm going to take from midnight at UTC time, and I'm going to ask for 1 hour's worth of data. There, so I'm going to ask for 1 hour. And the max samples I'm going to set to 0 so that I get all the samples. And now when I run it, it will ask me which query do I want to run. I'm going to run query number 2. And here you see now we have the time series data returned. So that means that you can create a small device like a Raspberry Pi, and you can read and write time series data. It goes in both directions. So that's the end of the GraphQL demonstration or lab.
Niels, there's a couple of questions.
Yeah.
One is more general, doesn't apply to the specific section, but as we are creating these attributes and data models, the question is that if we make mistakes, what sort of debugging facilities are available to figure out where the mistakes are? Okay,
so within if you look at the scripting environment, we have debugs and loggers, because these are typically headless scripts. You typically would feed it to a logger. We have a context-sensitive editor that we're not showing here now, but it also helps you. You will see that we have libraries that allow you to go in and use, for instance, the JetBrains tools, such as PyCharm or Visual Studio Code, in order to go directly against the model if you want to really do advanced scripting where we want to have all the capabilities of a full IDE. The IDE we have is quite powerful, but if you want to get beyond that, that can also do full debugging. You will also see that all changes done to the model ends up in an audit log, so that you can actually go back and see what was changed and have full traceability on anything that you added or deleted in the model itself.
And then there's a question on the export. How do we save the output of queries into a text file for use external to the platform?
It's very simple. You go here, you copy it, and you paste it. It's really quite simple. So this tool here is just for experimentation, but the way I would do this, if I had a project, I would go in and choose my favorite scripting language, interact with it using GraphQL, get the data structure back into a JSON format. If most scripting languages have excellent tools, PHP does it, Python does it, to take a JSON format and convert it to a CSV file, and then take that CSV file and output it from a script. I think that's how I would do it. it's better than trying to copy and paste JSON structure in its own way. And there was one thing I didn't show, by the way, which is around the documentation. So the GraphQL interface is built in with documentation. So if I click Docs here and I want to know about equipment, for instance, you can see here the equipment is defined, and you can find, okay, what are the queries, what are the conditions, what are the filters, and so on. All that is built into the GraphQL interface itself. So you can create here from graphical, but you can also create from your own client if you want to.
Okay. This next question, I'm not sure if we have the right forum to answer that, but we can certainly try. The profiles through a connector, through a gateway, will connect to the SM platform. Can these gateways be instantiated, especially the gateway as a virtual machine?
Yeah, absolutely. So the gateway is just a service. It currently is a Windows service. We're looking at also making it a Linux service. And if you want to create a virtual machine for that, you can. I think that would be an overkill for using a virtual machine, but you absolutely can do that.
Okay, right. What about true event-driven pub-sub messaging and architecture?
Great question. GraphQL has the concept of subscription, which is a pub-sub message. If you have then you can do it on purely event-based. If you don't, then you have to go in and have a poll mechanism that query it. But there is definitely subscription and pub-sub support in GraphQL itself.
All right. Next one is there are singular and plural versions of most of the tables and collections.
This is one of the ways that go into equipment. I would typically specify a single ID, and that would give me that single piece of equipment bag as one object, whereas equipment is a list. There's very little other difference between them. You can do everything in a list. You can do it in a single ID. This will only return a single. It's like returning a single row in a database.
Okay. Is there a command line interface for the SM platform? I'm
not sure if I understand. There is a programming interface. We are not going to create another pro. So if you went in and you used a Python, and it's not all available through that, so you have to be careful. But if you used a SQL interface that was a programming command line interface, you can do that. If you want to use a Python interface, you can do that. If you want to use a PHP interface, you can do that. Not all capabilities are available through all interfaces, though.
Okay. All right. I think this next item is actually related to the previous question, perhaps, unless I'm misunderstanding.
Oh, yeah, I think I understand that.
I think you can see that, Niels.
Say for master data, create, update, delete equipment profile. So we don't have a, I mean, maybe it's an interesting thing to do. We don't have a subscription. So say that we wanted to connect to SAP and subscribe to SAP's model so that it will automatically propagate. We haven't created that yet. What we have created is the notion of connectors that can push data, and they can also push profiles. We're not quite done with that yet, but that would be the way that we would get things across. Be interesting use cases to tie it together. You could definitely the other way around. You could subscribe to the model from another system and automatically update a third-party system based on us publishing the results of changes to the model.
Okay, great. So we have 10 minutes left. I just wanted to let you know, Niels, do you have more material to cover?
I have one slide and that is it. So I think we're actually doing pretty good on time.
Okay. And I'll answer one quick question. I think there was a question around where does the Savagent workflow fit into the presentation. I think you referred to the applications that sit on top of this particular infrastructure that sits in the application layer would communicate to this platform through the GraphQL API. And so hold off on that as you look at our upcoming presentation on workflows on Thursday.
But it's an excellent question. You know, one of the first projects we did in ThinkIQ history was to integrate Savagent with ThinkIQ, and the pain we went through to have a developer on each side define what the API should look like, and then someone in the middle trying to tie this together and then try to secure it was almost impossible. It was just so complicated. And it was one of the reasons that we really said there must be a better way. There must be a way that we can expose the model so that the person sitting on the Savagent side, who is a consumer, can just know how to query the model without having to include someone who is an expert on the specific API, REST API that exists in ThinkIQ.
Okay, great. Thank you, Niels.
Okay. So a little bit about extending the Smart Manufacturing Innovation Platform. And this has a little bit of a gray area between what is in the core and what is outside it. I just want to talk about some of the elements that are in it, in addition to, we briefly talked about the gateways and connectors that we're connecting to OSI and Wonderware with, for instance. We have a historian, so we actually do replicate data stored in the cloud. It's the only way we found to make it performant and do the type of analysis you want to. We have a semantic model, and what we mean by that is we give the model meaning, and we can do type system modeling, instance system modeling, and tie it together. We have a tickle engine, which is a material flow, sensor-based material flow analytics engine, where we can take changes in levels and flows and valve positions and so on, and from that automatically generate material flows. We store that into a material ledger, and these are extensions to the platform itself. And a material ledger can basically store material movements in a very flexible way. We have the model builder you looked at. We have data science, both within the scripting itself and also through the Jupyter Notebook. And then we have what we call an IntelliTuner, which is really an extension of the scripting environment, where we can go in and write scripts that automatically both tunes the model and enhances the model. We have a number of applications we can build on top of it. You can build dashboards. We call this an Asset Explorer. This is an example for how we did it for a grain elevator. We have Material Flow Explorer, which allows you to navigate in the material flow existing in the material ledger in a very dynamic fashion and see process data in the context of the material flow. We have the trend application, Time Explorer. You've seen that is in the core. And then we have the ability to build analytics dashboards on top of it within our content management system. You really could build any type of article showing any type of data. And that's also the same thing. You can build custom applications on top of it. And that concludes this training session. So just to reiterate, we looked at the use case. We went in and we looked at the platform itself and what the building blocks and architecture is. We went in and we created a reactor system from an existing type. We showed how we can build a relationship between equipment. We went in and we created a new extruder, 3-zone extruder. And then we went in and we showed how we could do import and export before we went in and looked at how we can use GraphQL to interact with the model. And then how we have extended the platform itself. So that, unless there are any more questions, I don't know if you have anything from your side, Rush.
I don't see any other additional questions. Maybe something that you may want to comment on is that, I think as a platform partner and outside of being a platform partner, you've probably seen hundreds of use cases for data modeling and how critical that is to being able to solve problems. And this is a core set of technology that CESMII is embracing, because at least in my 30 years of being in industrial R&D, I've found that if you don't do a good job of structuring the information that you're dealing with, that the ability to get insights out of it is severely limited. And so this is the core piece. So maybe you want to comment on some of your experience as to how these types of tools have become crucial for the manufacturing community.
Yeah, so we have both in ThinkIQ, we have many world-class manufacturers who have implemented this, and the ability for them to both get access to the data, see the data, and make sure the data is in context and have meaning, and therefore be able to do analytics on it. Really have solved problems that cost many that even problem they didn't know that cost them many $1 million a year, just because they didn't actually see what was in the data. I've always been a strong believer that we have to go in and give the manufacturing data meaning. If I go and tell you that the value is 5, it doesn't mean anything. If I tell you it is a temperature, it may mean something. If I say it's degrees Celsius, now I would say it's probably at least chilly if it's a summer day in California, but it might be quite warm if it's a winter day in Norway. If I then tell you that this is the temperature on the outlet for the individual quick freeze for a food product, you know that this is a very high temperature. And now if we go in and put the context of the material flow itself, we can now say that this is the impact of having not frozen the materials properly. So we can really tie, being able to give it context, I think is one of the critical elements in order to be able to use the data. And we're very much looking also for feedback from users on the things they would like to see and extensions and what they like and what they would like to have improved.
Yeah. Well, good. I think this has been a fairly instrumental webinar. I mean, if I may say myself, we made a tremendous amount of progress in getting some of the core functionalities of the platform created, and we've got several potential examples and use cases waiting to leverage this technology. So thank you for walking us through the capabilities today, Niels. And just a plug for ThinkIQ. They've been great partners for us at CESMII in helping build this capability. And also as a part of the core offering, we continue to leverage our other partners in developing additional capabilities. So what you'll be hearing on Thursday is from another one of our partners on the platform journey, and this is Savagent, and they'll be talking about workflows. So be sure to join us then on Thursday. And in summary, I want to thank Niels and his team for putting together this training session for us. And for those of you who've joined us today, thank you for doing that. And we look forward to seeing you on our next webinar on Thursday.
Thank you to you as well, to CESMII.
Thank you very much.
Okay.
Okay. Have a safe day.